Hi everyone. In the last part, we understood that what were the problems with inheritance when we were using it for the purpose of code usability, and what were the maintenance overheads we saw. Now we're going to look how we can improve the code base. Okay, so earlier we saw that there was this flyable interface which has fly method, and there was a quackable interface which had quack method. Okay, so how we can improve that piece of code? Because if let's say there are certain child classes which have common piece of code like fly with wings, that this is do nothing, and let's say if decoy duck comes and that also does do nothing, we were kind of not making use of code usability. First thing, we were duplicating code, which is a bad practice. And the second thing, what was happening in case in if future, if we want to change anything in with fly with wings implementation, then we had to look all the subclasses which had implemented this fly with wings, right? So this was one of the biggest problem we saw with just having the fly method. How we can resolve this? So the best thing is we can see the types of implementation which has been done in these subclasses. So we see there is fly with wings, and do nothing. So two functionalities we came up with was fly with wings and do nothing. So we created a concrete class with these two types of functionalities, and we implemented flyable interface. So flyable with wings is a concrete class which implements flyable, and it has the implementation the fly if the fly method of fly with wings have fly with wings, and with flyable do nothing will have implementation of do nothing. Okay, now I know that mallard duck, redhead duck will want to make use of this fly with wings. Now, what is the benefit of creating a concrete class out of this? The benefit is that now I have at one place common code which can be used at multiple places, and in future if I want to change something, I need to change it at one place. Others won't be impacted with this. I will not have to go and open each and every subclass to make changes. So this was maintenance overhead was reduced, and um, better code, cleaner code we have into the picture. Okay, so what we did, we removed whatever was changing or varying from our duck class to into its concrete implementations. Okay, so we encapsulated whatever was varying. Okay, and we are making use of constructor injection, or before even coming to constructor injection, we are making use of composition for the purpose of code reusability. We are not using is a relationship. How we are making use of composition? So we know that flyable with wings is what is supposed to be used in mallard duck. So whenever I call a fly method, it should call fly with wings in case of mallard duck. How are we going to implement it? So flyable is the interface, right? So I create a reference of flyable into the duck class, and in performed fly, I will just call flyable.fly. Now I need to inject the dependency into this. How do I do injection? I'll do injection with flyable with wings into the constructor of mallard class. So whenever I'm creating mallard class object, that means the flyable will be having flyable with wings. So it will always call the method of flyable with wings only, right? So now where is the composition being used? Now this is the composition. It is has a relationship, right? So now duck has this flyable relationship. Now why not flyable with wings? Why we are using flyable? So one thing we know that object creation happens during runtime, and flyable is an interface, so it is like a super type. There are multiple child concrete classes which implements this flyable, right? So it is a super type, and into the super type I can inject anything during my runtime. So here during my runtime, injecting flying with wings. In rubber duck, I'll inject fly do nothing, right? And this flyable, I can have it in the parent class itself, right? I'm just calling the fly method, and it is doing whatever the respective ducks are there. I don't have to every time like I don't have to create this flyable class in each and every classes, right? If I were be using this flyable with wings, now what I had to do, I had to basically, uh, in the child class I had to have the reference of this flyable with wings, and then do the dependency injection, and then this fly method again, perform fly method, I would be overriding and calling dot fly. So instead of doing all those things, I've made it more clearer. So this is flyable, which is will be used, and it is common to all kinds of duck. Fly perform fly method has to be called, and inside I'll call this flyable dot fly. Okay, so this was the entire benefit of doing so. So what does the strategy patterns basically say? So basically it says whatever is varying, you encapsulate it, make use of composition for code reusability instead of relying on the inheritance. Okay, so this was what the strategy design pattern was. I have given an implementation over there. You can go through it. So to show you, we have a duck class. This is an abstract class. Okay, so why abstract class? Because I have an abstract method called as display, and it is not going to remain common to any of the, I mean display as in the functionality of the implementation of display will not be common. It will be varying into its respective subclasses. So that is why it is an abstract method. Okay, and I have swim is common method. Okay, so mention method.